Hello everybody and welcome to a PowerPoint where we go over some of the ideas around magnetism. Now today's PowerPoint is going to be entirely involved in what a magnet is, how the magnetic field works, and the questions that are at the end of the PowerPoint and also set on Educate will be asking that exact kind of question. So all you've got to do today is sit back, take account of the notes that are coming, make sure you've got a pen and pencil ready so you can answer some of the questions as they come up, and we'll start now. So the objectives of today are quite simple. From today's session you'll have recapped the features and different types of magnets that exist, how the magnetic field works, what direction it goes in, how to plot it, and finally how to draw the direction of the magnetic field and what equipment you'll need for that. So we start with the poles of the magnet and types of magnet. So the poles are where the magnetic field is strongest. There are two poles in all magnets. There is the north pole and there's the south pole. They both are opposites, and the way that they interact with each other we'll cover in a moment. There are two types of magnets. There's a permanent magnet, which produce their own magnetic fields. They always attract and repel, and that's how you can tell whether something's a magnet or not purely magnetic. A magnetic material or object will always attract things. A magnet will repel as well as attract. That's a really important test to show whether you've got something that's magnetic rather than a magnet. Induced magnets are those things or materials that become magnetic when they're subject to a magnetic field. So they're either placed next to a magnet and then they become magnetic as a consequence of it. An example of this is things like drill bits in drills, screw heads in screwdrivers when you take the heads in and out. There's a magnet in the top of the tool and it attracts the screw bit to it, so the screw bit becomes magnetic. It is an induced magnet. Now the difference between an induced magnet and a permanent magnet is as soon as you move the magnet away from the induced magnet, it ceases to be a magnet anymore, so it loses all its magnetic properties. The magnetic property of an induced magnet is it can always attract. They don't repel. So just be aware of that. That's the difference between a permanent magnet and an induced magnet. A permanent magnet will attract and repel, and an induced magnet will only attract. And as it says at the bottom, when two magnets are brought together, they exert a force on each other. This is called the magnetic force. Two like poles repel, and this is because the magnetic field lines push against each other and they can't cross, and unlike poles attract north to south and south to north. Okay, and both of these are an example of a non-contact force. This is just reiterating what I've already said. Magnetic forces are between two magnets. Now there are two types of forces. There's an attraction force or a repulsion force. Opposite poles always attract, so that's north to south or south to north, and like poles always repel, so that's north to north or south to south. As I said already, this is because the magnetic field lines will not cross. They just squash against each other, and the more they squash against each other, the higher the force that occurs. The stronger a magnet is, the higher the force of attraction or the higher the force of repulsion when you put like poles together. Now the magnetic field is a series of lines, magnetic field lines that go around your magnet. It's always strongest at the poles because the poles are where the concentration of the magnetic force is, and they go in circles all the way around the magnet and they join up from north to south. All magnetic fields work from north to south in a magnet, irrespective of whether it's a circular magnet, a bar magnet like the one on the screen, or a ring. They all work in exactly the same way. The north always goes to the south. Okay, as it says here, there are four main magnetic materials or magnetic metals. They are iron or steel, same kind of material really, nickel and cobalt, and they're the only things that are known as magnetic and can become magnetic. As it says there, the strength of the magnetic field depends on the distance from the magnet and the material that it's made from, and it's always strongest at the poles. The direction of the magnetic field is always from North Pole to South Pole, and the next two slides are going to show you how you actually draw the magnetic field. The first thing we can do is make a magnetic field shape. Now this is a way of putting a bar magnet down and sprinkling something on it to show you the shape of the magnetic field. Now you can see from the diagram in front of you, this is achieved by a bar magnet being put under some paper and iron filings sprinkled over it. This allows the iron filings to stick to the places of magnetic field lines. And as you can see there, there's some distinct lines at the poles and all the way across the middle. You'll also notice that there's more lines at the poles of the magnet rather than in the middle of it, and that the lines join up from one pole to the other pole. Now the next thing we need to consider, apart from the shape of magnetic fields, is how we plot the direction of a magnetic field. Now to do this, you need to use a magnetic compass. A magnetic compass has a little arrow inside it that is also a bar magnet. The end of the arrow, or the point of the arrow, is the North Pole, and the other end is the South Pole. Works exactly the same way as a bar magnet. When you put these next to a bar magnet, they will move accordingly. And as you can see on the diagram, if you put it right next to the North Pole, the arrow will point away from that pole. If you continue to move the compass around the bar magnet, you'll see that the bar magnet's arrow changes its direction as we go all the way around. Now what this does is allows you to know which end of the magnet is the north and which end of the magnet is the south, and draw the corresponding magnetic field line shape. Now we're at the end of the input part of the PowerPoint. We're now going to look at some questions. What I'd suggest you do is, as we get to each part of the questions, you pause the video, try to write your answers down on paper, and then move on to the next one. At the end of this section, there are answers. So let's start. And now we get to the answer section. Hopefully you paused the video as we went and you're able to write the answers to all the questions. The next are 2 slides to just show the answers to the questions. Let's begin.